Oh, that made me nervous. It took a little second there. Welcome to lesson 2, equal ratios and proportions. Our definitions are already filled in here. Ratio we spoke about in lesson 1. A ratio is a comparison of two quantities by division, so we can write it as A over B, A colon B, or A to B. The reason why we have B cannot equal 0 here is because we know from chapter 1 that your denominator can never be 0 because when 0 is underneath, it is undefined. So that is just some additional information there to let you know that that bottom number can never be 0. A proportion, which we'll be getting today, is an equation. Equations have equal signs. We know that from chapter 4. An equation shows that the two ratios are equal or equivalent or the same. So if you take a look at problem number 4, that's where we're heading today. 10 over 15 equals 15 over 10. That is a proportion. It's an equation showing whether two ratios are equal or equivalent. In order to prove whether two fractions are equal or equivalent or two ratios are the same, we're going to find their cross product. Product means multiplication. We know that from our previous chapters as well. So in two ratios, two fractions, the cross products are found by multiplying the denominator of one ratio by the numerator of the other. If you cross multiply and the products are the same, then it's proportional. So if the two ratios form a proportion, if the cross products are equal. So we're going to cross multiply today. When we cross multiply, if the products come out to be the same, then we know it's proportional. So take a look at problem number 1. Check if each pair of ratios form a proportion. Write equal if the ratios are proportional. If not, write an equal sign with a slash through it, which means not equal to. So in problem number 1, if I cross multiply the 2 times the 9, that gives me 18. If I cross multiply the 8 and the 3, it gives me 24. Since 18 is not equal to 24, my cross products are not equal. Therefore, this is not proportional. So I'm going to put an equal sign with a slash through it. Number 2, 6 colon 33 is the same as saying 6 over 33. 2 colon 11 is the same as saying 2 over 11. And now I'm going to cross multiply. So 6 times 11 is 66. 33 times 2 is 66. Now, technically, in order to cross multiply, it has to be a proportion. So I'm going to put an equal sign there. We're trying to figure out whether these ratios are equal to each other. 66 is equal to 66, so I'm going to put an equal sign to show that they are equivalent or proportional. Number 3, 8 to 45 was the same as saying 8 over 45. 40 to 9 is 40 over 9. Again, I'm going to put that equal sign so I can cross multiply. 9 times 8, hopefully you have your calculators handy if you're not 100% on your multiplication, gives me 72. 45 times 40, well, right away I know that's going to be a lot bigger than 72 because I'm dealing with double digits there. I get 1,600. Cross products are definitely not equal, so this is definitely not proportional. Do these form a true proportion, right? Yes or no? So we're going to do the same thing, but instead of putting an equal sign or does not equal to symbol, we're going to write the words yes or no. So cross multiply, 10 times 10 is 100. 15 times 15 is 225. Those are not equal to each other, so I'm going to put the does not equal to symbol, and I'm going to write no. I'm going to get rid of the star from before so you guys don't think it's anything special. 6 colon 12, 6 over 12. 14 colon 28 is 14 over 28. Again, I'm going to cross multiply. I'm going to put the equal sign there just to show that I'm going to do my cross multiplication to prove whether they're equal or not. 6 times 28, almost divided them, got 168. Cross multiply the other way, and it doesn't matter which way you multiply first. I also get 168. Those are in fact equal to each other, so I'm going to put an equal sign there, and I'm going to put yes, they are proportional. Number 6, I'm going to squeeze my equal sign between them. It's already set up for me, and cross multiply. 34 times 16, 544. 17 times 32, 544. They are equal to each other, so the answer is yes, they are proportional. 3 to 8, 3 over 8. 15 to 32 is 15 over 32. Again, I'm going to put my equal sign there so I can do my cross multiplication. 3 times 32 is 96. 8 times 15, or 15 times 8. Again, order does not matter. This is all multiplication. 96 does not equal 120, so the answer is no. So you do need to show why you're saying yes or no, so please make sure you write down what I have showing why yes or no is the answer. So the rule, to solve proportions, you are going to cross multiply. And in the problems that we're about to do, there's going to be a number missing. So we're going to cross multiply, and then we're going to solve the equation. And that is why we did the equation unit first, so that you guys all know how to solve an equation. So for example, number 1, the following ratios are proportional. They're telling you that they are equal to each other. Solve for the variable. So you, again, doesn't matter which order you multiply in first. I just always like to go in this direction, but again, doesn't matter. So 33 times n is 33n. Now I put my equal sign and I multiply in the other direction. So 11 times 12, or 12 times 11, I get 132. Now I have a one-step equation. 33n equals 132. In order to get n by itself, I have to divide each side by 33. And that means n has to equal 132 divided by 33 is 4. So in order for this to be a true statement, in order for these to be equal to each other, n would have to be 4. Number 2, n to 2 is n over 2. 9 to 1 is 9 over 1. And we're proving whether these are equal. We know they're equal. We know they are proportional, so we have to solve for n. Cross multiply 1 times n. So you could put 1n, but I know 1 times n is just n. 2 times 9, or 9 times 2, is 18. So in order for these to be equal, in order for these to be proportional, n would have to be 18. 32 colon y, so 32 over y. 8 colon 9 would be 8 over 9. And I'm going to now cross multiply. They are proportional, so I put my equal sign. 9 times 32 is 288. Y times 8 is 8y. Always put the number, the coefficient, in front of the letter. The opposite of multiplying by 8, in order to get my y alone here, I have to divide by 8. 288 divided by 8 is 36. So y would have to be 36 in order for these to be equal to each other. And then don't let the fractions scare you. We're still going to do the same steps. So cross multiply. 126 times x is 126x. 6 3/10 times 42. So 6 ABC 3 ABC 10 times 42. Okay, so some of you might have 264.6. Some of you might have 1,323 over 5. Some of you might have the mixed number. I'm going to use the decimal here. So 264.6. Either way, no matter what form you put there, you're going to still have to divide both sides by 126. So 264.6 divided by 126, or take whatever form you have and divide it by 126. You'll get 2.1, or 2 1/10. Or if you have an improper fraction, it would be 21 over 10. So any of those forms would be fine. Number 5, 11 colon 5 would be 11 over 5. X colon 10 would be x over 10. They are equal to each other. They are proportional. I'm going to cross multiply. 5 times x is 5x. 10 times 11, or 11 times 10 is 110. Divide both sides by 5. Get x alone. X is equal to 110 divided by 5 is 22. So in order for these fractions to be proportional or equal to each other, x would have to be 22. 35 times x is 35x. 5 times 49 is 245. Divide both sides by 35. X is equal to 245 divided by 35 is 7. And hopefully this all seems familiar to you because you did spend a lot of time with this as a 6th grader. Number 7 and 8, actually number 7 is a very special problem because you'll notice that in all of the ratios and proportions that we've done today, there's only been one number or one term over one term. In problem number 7, we have a binomial on top. We have an x plus 4. So when you go to cross multiply the 11 and the x plus 4, you have to make sure you're using the distributive property there. So it's 11 and then in parentheses x plus 4 because it's 11 times everything in the numerator equals, and then cross multiply your constants there. 5 times 22 is 110. So again, because we have that binomial, we need to multiply the x by 11 and the 4 by the 11. So that gives me 11x plus 44. So now you know why we did the equation unit first. In order to get the 11x alone, I'm going to minus 44 from both sides. So we have a 2-step equation. You need to show both steps. 110 minus 44 gives me 66. I now divide both sides by 11 to get rid of that multiplication, and I get x is equal to 6. So in order for these two ratios to be equal to each other, I would have 6 for x. And then number 8 is what we've been doing, nothing special, just with decimals. So 5.4 times y is 5.4y. 9.3, so hopefully you're using a calculator, not just copying, times 12.6 is 117.18. I now divide both sides by 5.4. So now 117.18 divided by 5.4. Y would have to be 21.7 in order for these ratios to be equal. So hopefully this all seems familiar to you. We're going to do the try these as always as a class for additional practice. Your Google form starts where it says lesson 2 homework. Again, you only have to do the 5 questions that I put in the Google form. You do not need to do all of these. Good luck. Nothing tricky. Just use your notes to help you get through the problems and